Hi friends, I am Aishwarya. Hope you are all doing it. So, in today's video, let us discuss about rational numbers. So, let me write. Rational numbers. So, here the question is, what are rational numbers? Rational numbers are the numbers which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. These are called as rational numbers. So here the P part is called as the numerator and Q part is called as the denominator. So let us see some examples of rational numbers. These rational numbers can be written in the form of fraction and also in decimal forms. So let us write in fraction form. That is 1 by 8. Here 1 is P and 8 is Q. 1 is the numerator part and 8 is the denominator part. Another one is 4 by 8. Here everyone makes a mistake that it is in the form of fraction form, but it should be simplified. So 4 ones are 4 twos are. So 1 by 2. This is in the rational form. 1 is the numerator and 2 is the denominator. And 1 is P and 2 is Q. And in the decimal form, that is 0.12. This can be also written as, in fraction form, it can be also written as 12 by, here 2 digits are there after the decimal point. So 2 zeros will be coming. So 12 by 100. So here 12 is P and 100 is Q. So these are about rational numbers. Let us recall it again. Rational numbers. They are numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. So the examples are 1 by 8, 4 by 8 and 0.12. So let us go into the next topic, that is density property of rational numbers. So what is called as density property of rational numbers? Density property of rational numbers means in between any two given rational numbers, like let us take 1 and 2. Between any two given rational numbers, there are infinitely many rational numbers like 1.1, 1.2, 1.3 till 1.9. After 1.9, 2 will be coming. So this is called as density property of rational numbers. Let us recall it again. What is called as density property of rational numbers? Density property of rational numbers means between any two given rational numbers, there are infinitely many rational numbers is called as density property of rational numbers. So let us go into the other topic. The next topic is terminating decimal. What is called as terminating decimal? If the number of decimal places after the decimal point is finite, finite means which will end, is called as terminating decimal. So let me write. the number of decimal places after the decimal point is finite, then that decimal is called as terminating decimal. So let us see some examples such as 0.1234. This one is the terminating decimal because it is ending at one point, that is 4. And the numbers which will not end at one point are called as non-terminating, recurring or repeating decimals. So this can be represented in the fraction form also by 4 decimal places are there, so keep 4 zeros. This is the decimal fractional form of this decimal. So here one important point is there, that in the denominator part, if the prime factorization in the denominator part should be always in the form of 2 power m into 5 power n. If it is not there, then it is non-terminating recurring decimal. So this prime factorization should be in 2 power m into 5 power n form. So let us convert it. 2 power. Let us do prime factorization for this number and identify it in 2 power m into 5 power n format. So let us do prime factorization. 10,000. So first let us divisible it with 2. 2 5s are 10 and write remaining zeros. 2 2s are 4 and 1 will be going here. So 2 5s are 10, 0, 0. So now it will be divisible with 5. 5 5s are 25, 0 and 0. 5 hundreds are. 5 20s are. 5 4s are. 2 2s are. So this is the prime factorization of 10,000. So let us write it. So how many 2s are there? 1, 2, 3, 4. So 2 power 4. How many 5s are there? 1, 2, 3, 4. So 2 power 4. So it is a terminating decimal, and this proves it is a terminating decimal. So let us recall it. So what is the terminating decimal? Terminating decimal means the number of decimal places after the decimal point is finite, then that decimal is called as the terminating decimal. Example is 0.1234. So this can be written in the fractional form, that is 1234 by 10,000. And 10,000 should be written as 2 power m into 5 power m. If it cannot be written, then it will be a non-terminating, recurring or repeating decimal. Let us go into the next topic, that is non-terminating recurring decimal. So what is non-terminating recurring decimal? The number of decimal places after the decimal point is not finite, then and a group or digit of numbers which repeat continuously is called as non-terminating recurring decimal. What is non-terminating recurring decimal? The number of decimal places after the decimal point is infinite or not finite. Here infinite means which will not end at any particular point of number. The number of decimal places after the decimal point is infinite and a digit or a group of digits repeat continuously is called as non-terminating recurring decimals. So let us see some examples. Those are 4.79 bar. Here bar represents that 9 will be continuing endlessly. So in the short form we can keep it as bar. And 16.73 bar. You can keep the bar for n number of numbers. It does not have a rule that it should have only for one number. So this is about non-terminating recurring decimal. Let us recall it. The number of decimal places after the decimal point is infinite and a digit or a group of digits repeat continuously is called as non-terminating recurring decimal. Those examples are 4.79 bar and 16.73 bar. So let us go into the next topic. The next topic is period. Here the period means that the numbers in the recurring part is called as the period. Recurring part means if there is a number like 16.79 bar. So here 9 is in the recurring part. So the period will be 9. So let me tell you again the definition of period. The numbers in the recurring part is called as the period. For example, 16.79 period is 9. Our next topic is periodicity. Periodicity means the number of digits in the recurring part is called as periodicity. For example, 100.236. Here 36 bar. So here periodicity is the number of digits in the recurring part. That is 36 are in the recurring part. So 36 are 2 digits. So periodicity is 2. I'll repeat the definition again for periodicity. The numbers of digits in the recurring part is called as periodicity. Example is 100.236 bar. So periodicity is 2 because there are only 2 numbers in the recurring part. So this is about periodicity. So let us solve some examples of period and periodicity by identifying them. First one, 1.67 bar. So here period is the digit in the recurring part, that is digit is 7. So period is 7. Whereas periodicity is the digit in the recurring part is only 1. So periodicity is 1. Second example, 0.68 bar. Period is 68 and periodicity is 2 digits are there in the recurring part, so 2. Third one, 0.789234. This is the number bar. So here period is 789234 and the periodicity is 1, 2, 3, 4, 5, 6. 6 numbers are there. So periodicity is 6. So this is all, friends, in today's video. So hope you all understood these topics which I have said. So until then, bye bye.